Okay, it's noon time. We'll get started, okay? So today we are on the lecture 3, the week 3 Python reference environment. The reference environment. So reference environment is part of the memory model, okay? So chapter 2, 3 are talking about memories. And it's very important. It's a very important topic. When you study a new language, basically you need to study the memory model first that I talked about it last week. So chapter 2 is on data structure or data types. So chapter 2, basically, you know about different data types. And the possible data structure or compound data types are included in chapter 2. Chapter 3, now we talk about the variable reference type. Okay, and the important naming of the name, scope, binding, reference environment. It's different terminology. You must know it when you know one new language. Okay. So we'll talk about the definition of names, binding, scope, reference environments, and then each of the binding memory models, scope, and reference environments topic. Okay. So this whole chapter, you must know about the definition of each of these and knowing about the examples in different languages. Okay, so name, scope, binding. For these different terminology, you must remember each term, okay, and also remember its definition. So basically, in the homework, you will see that there are quite many fill-in problems. A lot of students are wrong in the fill-in problem, and some even ask me question about why I'm wrong. Okay, so basically, you have to study harder for this fill-in problem. Usually nowadays, a lot of students just know how to answer the multiple choice questions. And multiple choice questions, you always have the A, B, C, D that you can pick. So you don't remember the concept. So these are different terminologies, we want you to remember them. So basically, I just designed the fill-in problems. So make sure that you can remember them, okay? Even you need to try to study hard to remember it. So the fill-in problem is harder, but you have to get every character, every word correctly. Otherwise, you will be wrong, okay? So now, first one, what is the name? Name is called identifier. Okay, sometimes called ID. That's called a name. So name and the memory is like memory. You have some address, some location. It might have address. Okay, this is the hexadecimal code of the address. And then you have a name. Say that's assume this is X that is associated with this memory. Okay, so name is the identifier that you use in the program. Okay, that's called name, variable name. Okay, sometimes we call it ID. ID is not only for variable. ID means the name for variable, sometimes for class name, sometimes for function name, sometimes for the package name. Okay, it's called ID. So ID is a more technical term for name. Okay, so here we call about name. Name means that the name for available, but ID really sometimes refer to the available class, function, and packages. Okay, so name is that. Binding is between two things. That's the name and the address. That's the association for the two. So basically, you have variable called S, and then the address AF, A2. These two associate together, the relationship being created, we call it binding. Okay, so binding is similar to marriage. So marriage, you go to a chapel and then the priest declare that you from now on you're husband and wife. So from now on you are husband. So marriage is a binding. But when your binding finished or like that you got divorced, then the relationship of the name and the address disappear. So binding is similar to marriage. Once the binding you get out of the marriage, the binding relationship is no longer existing. The variable may be returned for some other use. Okay, so that's called binding. Binding is the association between two things. Okay, in marriage, it's called husband and wife, these two things. And in programming, it's name and the location and the address. Okay, so this is called binding. And then where the binding is actually active, that's called scope. So scope say you're where you're binding a whole or valid. So there are local variables, there are global variables. Okay, so for local variable you have block level variable, you have functional level variable, you have parameter variable, you have per iteration variable. Okay, that's local binding, local scope. So let's look at these different local variables. And for this local variable, I would like to use the Java language, for example. So I'll bring up this BlueJ. Okay, BlueJ is educational tool, usually is useful for high school. Okay. BlueJ had the advantage of showing the UML, the relationship of the classes. Okay. I use it because of it's better for high school students to teach them the has a relationship is a relationship of the different variables class type. Okay. So here I'm going to go to this. Okay, here I'm going to create a new directory. This one called BlueJ. Okay, let's use this BlueJ directory. And I'm going to create something called chapter 3. Okay, chapter 3. Okay, in chapter 3, you can create a class. This one is called, actually name it as a scope. So scope is the name of a class. Okay, it's the name of the class. So it's used for as an ID. Okay, it is an ID, but here we are going to talk about the scope. So you may have a main group and like this. Okay. Okay, I like BlueJ because BlueJ show you where the function start and where it end, and they have given color to show your blocks. Okay, so that's better. Okay, so now let's assume that we have an integer a equals 3, integer b equals 4. This is a local variable. Okay, local to where? Local to the function. Okay, so this different local variable, it is alive from here, and then a and the 3, these two, when you declare a, the memory location will be stored with 3. So the binding starting from when you declare the variable, and the binding will be end when the function finish. So the lifetime of this a variable is starting from here to the end of the function. Then we call this variable a local variable, is local to the main function. Okay, b is the same thing. Okay, b is the same thing. So that's actually print these two variables out. Okay, so system.out.print x equal percentage b, comma, y, okay, I'm sorry, not x and y, it's a and b. G backslash n, okay, you actually put in a and b. Okay, so this one you can print out a value for these two. Again, we are going to print it later, one more time, okay? So here we will print available one more time. And in the middle, we'll call a function that's called it f of a and b, okay? So here we will need to have a function that's called public static void f function, and this f function we will have a variable called integer x and integer y. Okay, so we are going to print the integer x and integer y right here. Okay, and we are going to print it one more time here. Okay, let me change the name of the variable x and the y and x and y. Okay. Here we have the x and the y. Okay. X and the y. So right here, we are going to define the AB again one more time. So let me actually copy these two and put it right here, and we will call it A equals 5 and B equals 2. And we are going to print the AB one more time. I'm sorry, not these two. I'm going to copy this again. I'm going to print AB one more time. Okay, so basically in the function, you actually will print these. Let me put some description. So in F, okay, that then you will know in the F function. Okay, we will run it right now, okay, for the first time. So that's wrong. Okay, so AB is 3 and 4. In F, XY is 3 and 4. In F, AB is 5 and 2. Okay. Okay, and then X is 3 and 4. AB is 3 and 4. Okay. So this tell you like, okay. Your A defined right here, B defined right here. So this one is 3 and 4. This is 3 and 4. So we pass the 3 and 4 to XY. So XY is 3 and 4. Okay. So this is 3 and 4, 3 and 4. Okay. But internally, you change your definition for the A and B. So this green A and B is different from the red A and B. It's a different variable. So basically, right here, you print it again, you get 5 and 2 for your green A and B. So something like your definition for your AB is valid right here, and then up to this point, it is not in power. And later, when you return to the function, you go back again. So your AB lifetime is from here to here. It's basically from here to here. But it's suspended when you call the AB function. So AB function is the green AB. Green AB is valid starting from here to the end of the function. Okay, so this AB is a F function level variable, local variable. And then your XY is valid starting from when you pass the AB right here in here to the end of the function. So XY is a parameter level function. It is, parameter level variable. the binding time is varied from the beginning of the function to the end of the function. And then this ABR, local variable, local to the f function, its binding is starting from their declaration to the end of the function. Okay, and then this ABR, local variable to the main function, its valid time is from its declaration to the end of the function. And in the middle that you call another function, they have a different AB definition. So the AB definition in the f function has a new definition. So this red color AB are suspended when you call the f function. They have a new definition. Okay, the binding is different. So the name and the memory location may be changed during the function call. So how this works is that you have a call stack. You have a call stack. So you have a main function. So your main function has two variables, A and B. Store and 3, which is 3 and 4. This is your main function. So when you call your f function, let's use a green color for it. So your f function has two parameters. These two parameters are x and y. So you copy your 3 to x, copy your y to b to y for 4. So that's your local variable starting from the core of your f function. So the program continues to run until they see A and B. So A and B are defined as local variables inside the f function as well. And they got put 5 and 2 there. So these are the coframe for f function. We call it coframe. Or stack frame. Okay, sometimes called stack frame. Okay, sometimes called activation record. Okay, there are different names for it. So in the f function, these variables are valid. So green AB are in power at this moment. Red AB are suspended. Okay, it run until you finish the function. Then your coframe will get pop out. So these different variables got pop out, got erased. Okay, and then memory restore to this condition. So your AB become in power again. Your AB become in power again. So your red AB are printed right here. Okay, this is how the local variable works. And we do have the parameter level local variable, functional level variables. Okay, any questions so far? Any questions so far?
All good.
Okay, so you must know about the different definition of the terminology, okay, name and binding and scope. Now one more, okay, these are not enough. So you may have a variable, say, right here, your AB, let's go over here, right here. You may have a variable called for integer I equals 0, I less than 5, I plus plus, okay, you do system.out.print line of your, let's use a printf, okay. So it is one in loop. Okay, you print out your I, and then you get out over here and you say integer I, okay, equals 10, and you print the I again, and then you say out of the loop I, okay. It is okay. You have a I over here and I over here. Is that okay? Let me see. That's actually wrong. It's okay. The compiler okay, and you run it. It's okay. Okay, so in the loop you get I 1 2 0 1 2 3 4. Out of loop you get 10. Okay, so basically this I is valid starting from here up to the end of the loop. So basically this I is called loop variable. And this loop variable get a value of 0, 1, 2, 3, 4. So it actually is 0, 1 turn, and then you roll back. 0, 1 turn, roll back, 0, 1 turn, 0, 1, 2, 3, 4. Keep getting the different value. But the lifetime is starting from the beginning of the loop to the end of the loop. Okay. So this is the green I, okay. And the red I is defined right here to the end of the function. So this red I is totally a new variable, totally not related to the green variable. It's not related to the green variable, okay? So these are this I is a loop level variable. This green I is a loop variable. The red I is a function level local variable. Okay, this is per loop variable. Okay, and inside here you may have a variable called integer j equals 20. Okay, and you do system.out print f. Okay, this one in iteration. Okay, percentage t n. You put your j, and after that your j increase. Okay, so this j is different. When you run it, the j is always 20. J in each iteration is always 20. Okay, so j variable is not the same as I variable. So I variable is a loop variable. So it actually gets started right here. And for 5 iteration, you update its value. It's the same variable. So here your j variable starting from here, it is dead. It disappear when you actually finish the loop, finish one iteration. So when I equals 0, you have a new j, and then the new j disappear. When you have a I equals 1, you will create a new j, totally new j. So this j is a per iteration variable. The lifetime only is valid for that iteration. So starting from its definition to the end of the loop of the one iteration. So this j is a per iteration variable. Okay, so it's also a local variable, but it's not per loop variable, it's a per iteration variable. Okay, this is another local variable. Okay, that's a per iteration variable. Now, again, you may have a variable right here. Let's call it static integer I equals 3. Is that okay? That's okay. Then you have I equals 3. Here you have I, here you have I. So these 3 I are totally different I. Okay, so let's go to here. Let's actually print out the I. So this one is the global static I. Okay. Okay, now let's actually print this one again. When you go to the loop, let's print it in the loop. Okay. So here, okay, we already have it. So you print right here. So at this moment, you have a I here, you have an I here. This I is the green I for the global variable. This I is the red I that defined in the loop label. Okay, that's wrong. So your local I3, okay, this is the local, this and it's right here, it's global I, okay, global static I. So your local variable right here is also stored in your program, it's local variable. In the loop is also stored in the local variable. The global variable, the static I is stored in your measure area, or we call it constant pool. Okay, they are not in the function. So in order to understand that, you let me bring up a slice in Java language. Okay, let me bring up a slice in Java language. This is a slice I will follow from the AP Computer Science course. Okay. Okay, so this one is the memory allocation, the memory model for Java language. Okay. Okay, so your memory, if that's local available, you are stored in your stack. Your local variable including the variable in your main function, in your parameter list, in your F function, in your loop. Okay, they are all in the Java stack. And then the global variable, it is stored your class variable. Every static variable, that's class variable that's stored in the master area. Sometimes we call it master area. Sometimes we also call it constant pools. Okay, and it's stored here. So the storage of the memory is different. So these are different memory models that you need to know. Okay, when you study the language, you need to know about the memory model. So here, let's go to Java. Let's call Java memory model. So when you search the internet, you can search Java memory model. You will get. Let me see. Let's try user image. Okay, you will get the memory model, different memory models for the Java language. Let's use this one. Okay. Here you had a memory. I'm sorry. Here you had a memory model. Okay, including the stack, your cache, your meta space, okay, and your heap memory, okay, and your global storage area. Okay, so here it has the talk about your stack, your meta area, okay, your reserve space, your Java virtual machine technology, okay, and how those different variables got loaded in your Java virtual machine. Okay, so these are some of background knowledge that you need to know before when you learn the language. Okay, when you learn the Java language. Okay, so this you can see many articles. Some people do write these different memory model descriptions. Okay, you can kind of study. Okay. when you start a language, you must know about its different memory models. So in here, we talk about the name and the scope and the binding of the different variable labels in Java language. Okay, Python similar. Python also has this different kind of the binding. So you need to know about how Python's local variable, global variable, and local variable. Okay, and we use the Java language because Java language is a type. It's a it actually is a more static type variable. So when you declare, you need to declare a variable type. Okay. And Python is dynamic type, more dynamic type language. So the type of the variable may change, okay, may change. So you need to know about when the binding start and when the binding finish, okay? Okay, so you need to know about static binding and dynamic binding. Static binding and dynamic binding usually are for your functions, okay? And the binding is the name associated with the memory. Okay, so your name association with the function is also called binding. Okay, so usually your function has a static binding and dynamic binding. Java language is always using dynamic binding, while the C double class language, they do allow you to declare a static binding. That's a normal function call, okay? And then dynamic binding, that actually is virtual function, okay? Virtual. When you see the available that's using a virtual, that's dynamic binding using V table, okay? And then polymorphic method and polymorphic data, okay? That means the type of the object may change when you call a function, okay? You have binding of available will also change according to the polymorphic binding, okay? And there is also something called parametric binding. It actually is when you call some function, the parameter and the variable values, we call it actual parameter and formal parameter. Formal parameter are the variable name. Actual parameter are the number that being provided to the function for the function call. Okay, and then those relationship is a parametric binding. Okay, and when you finish the function, it restore ABC. You go back to the original binding. Okay, so ABC right here is the parent's environment, and then the ABC in the subroutine is in the call frame. Okay. Okay, so these are different bindings. So different language have different models, static, dynamic binding, okay, strong typing with binding. Okay, this one we covered in the previous chapter already. Okay, so then we have different scope available. Now next term is dynamic typed, strong type. So this here we say type. Type means that definition of your type. So Java language, the type is always static. So it's a static type in Java language. So when you actually call a variable, the type already been determined. So it call static type variables. Okay, now let's look at the Python language. Python language is different. So let me bring up the Python. Let me use this idle, okay? So Python language, you do have A equals 3, B equals 4, and you print A and B. Okay, and then later you say A equals, how are you? And then you print your A. So this A become, how are you? It become a string. So right here, your A create a binding with a memory location of an integer. You put a 3 on. Okay, so you have a binding of A. That's actually memory address is AF A2. And then later you assign A with the string. So basically, memory location of store. How are you? I'm sorry, I used the wrong word. Type of hello. So you actually write how are you? And A got pointing to here. Okay, so basically the original binding is done. And the type originally is an integer type. And now it becomes a string type. So when you print it, the type being determined as a string, you print as a string. So the type being determined at the runtime, we call it dynamic type. Okay, so the type is determined at the runtime, we call it dynamic type. And right here, we can say type of A. And you show you the class string type. Okay, if you do A equals 5 again, and you do type of A, that become an integer type. So basically the type is determined at the runtime. We call it dynamic type. Okay. So Python is a dynamic type language. Java is a static type language. Okay. Now, if you want to check the variable in, let's assume that you want to check the variable in JavaScript. Okay, JavaScript. Let's talk about JavaScript. Okay, so you can, I'm sorry, not about break. It's about colon break. Okay, it will give you a blank page and then to inspect. Okay, you can bring up the console right here. Okay, you bring up the console right here. So you also do A equals 3, B equals 4. Okay, let me actually make it bigger. Okay, so you can see. Now you do console log. Your A. Okay, so it becomes 3, right? And you do A equals a string. And you do console log A. Okay, so it become a string. So basically, what I want to say is that JavaScript, JavaScript language is also dynamic type. Okay, I'm sorry, this console is reacting very slow. Sorry, my machine is reacting very slow right now online. Okay. So basically, what I want to say is, wait, I have a typo. Anyway, what I want to say is that the JavaScript language is also a dynamic type language. Okay, so usually you declare a variable using var variable a, okay, equals 3. That means that the type is not determined. It's only say this is a variable var. Okay, this is actually a runtime determined type. Okay. Okay, let's go back to here. Let's actually go back to here. Go back to the Bluejay directory. So sometimes let's go to this chapter 3. Sometimes you actually do have the window R, okay, to bring up the command line, okay. You go to the E drive, okay, and then you change it directly to here. Okay. So you may call Java shell, J shell. You are into the Java shell. Okay, so you do var a equals 3, var b equals 4, and you do system.out.print line of your A and B. Oh, no, it's wrong. System.out.print line of your A. So your A is a 3. So this one is also a runtime variable. So let's do var A equals, let's see here, let me use ABC. Okay, and system that out that green line of your A. So what I want to show you is that newer Java language after Java 20, they start to allow the variable type var, and Java start to accept the dynamic type variables. Okay, it doesn't allow it before, but now Java also allow it, but only in local variables. Okay, for the dynamic type of variables. For some reason, Java actually start to allow it. Okay. Okay, so this tell you the static type and dynamic type variables. Okay, next one. In Python, you do have the namespace. Okay, C++ also had a namespace. So when you see this namespace word is equivalent to the word called module. Okay, so namespace creating a binding environment that is only valid inside the module. So a Python file is a module, is one separate namespace, or is a one namespace. So when you do import, so let's assume that you do import NumPy. Then you do have a NumPy module, you have a several variable right there. And your own main function also have a module. But when you call a function inside the NumPy, you must use a NumPy, the module name, that function name, okay? That function name say NumPy dot render. You have to call it by NumPy dot render. So if you want to use a show name, sometimes you do import NumPy as NP. Then your namespace name is changed. So you can call the function by np.np.render, say, for example. Okay, so this one is actually import the module without merging them, then you still need to use the namespace name on it. So if you do from numpy import star, then it's different. From numpy import star, it is not, when you call the numpy environment, you don't need to give the namespace. You are merging the two variable space together. So in your function, you can directly run random function, and then before it, there's no longer numpy needed. When you do from numpy import start, it's merging the two namespace. Okay, the two namespace are merged together. So here, two things that I want to teach you. One is namespace is a module. Okay, it's a compartment. It actually is a environment. And then when you do from numpy import start, the two namespace merged together. Your own project and the numpy namespace are merged together. If you do import numpy as np, then it doesn't merge together. So you still, when you call the function, you need to use np function name. Okay. Any questions so far? Any questions so far? Hi, Aaron, are you okay so far?
Yeah.
Okay, so I'm trying to explain the concept, okay? And then you do have the LEBG rule for Python. That's actually a different level. This different level means that you have local variable, but you need to use it to determine whether the variable is inside the loop, outside the loop, or it actually is global. And this LEBG rule is used for Python language. But Python, you do not have a definition, very clear definition of where the variable got declared. And the variable name always can be the same. So basically, they will check your local content first. If your local doesn't have it, they will check your enclosure for it. If enclosure doesn't have it, they'll check your global variables. Okay, so basically, these are LEBG rule for Python's local variable definitions. Okay, so this part, you can read it. Okay, I don't waste time on those. If it is easy, you can read it by yourself. Okay. I basically focus more on the definition, making sure you understand the definition. Okay. So here it show you different variables. You can watch the video and look at the program. Okay. Okay. Next one is lifetime and storage management. Okay. So sometimes you talk about your lifetime of your object when it's created and when it finished. That's called the lifetime of your object. Okay. So you have different binding. You have scope of the binding. So when you actually have a namespace and you may have assigned new namespace, so different namespace, different code frame, different parameter assignment, and the time that your variable is using, we call it reference environment. The complete set of the variable bindings in Power that you are using, that we call it reference environment. Okay, remember this term. This term is the answer of one of the fill-in problem. Some students just didn't get it right. Okay. The reference environment is the whole set of your binding of the variable that is in Power when you run your own program. Okay. When you finish a function, the reference environment will change. When you finish the function code, that will change. Some variable declare the reference environment change. Some variable out of Power, the variable environment will also be changed. Okay. So you do have a memory, you have whole stack, your heap, you have this whole thing is called memory environment. Okay. Okay, here there are more terminology and it's the definition. You can study by yourself. Okay, I think this part is okay. Then when you call your function and return your function, before you call your function and you have a preparation when you enter your function call, that's called prologue. When you finish your function, you get out your function, there is some return of available and also actually to finish your memory bindings. Okay, that's called epilogue. Epilogue is when the procedure that you want to finish your programs. Okay, that's called epilogue. So for a function call, you have prologue and you have an epilogue. Okay. Okay, these are okay. And then we have the scope rules. The scope rule, you can read it, okay? I already talked about the reference variable and the scopes. And then binding, you have deep binding and shallow binding, okay? Deep binding means that you bind in and then your content will be bind, okay? Shallow binding means that you only bind in your reference, okay? The different rule for binding. So deep binding nowadays probably only this language is deep binding. Other mostly shallow binding. Okay, shallow binding means that just pass the variable to variable reference to. Okay. Okay, and then you need to understand what is pointer. That uses the star of the pointer. Okay, it's a my class. Body of the variable my pointer is a object. It's a my class object. So this one is a pointer. When you declare my class, my object, and you put an alias sign on it, this create an alias. So this variable my object is an alias. My pointer is a pointer. Alias means the object itself. So you create an alias name. Alias name for the variable. Pointer is indirectly pointing to your object. So you store your address. These two are different things. Okay, address and alias are different things. Address and alias or reference is the same thing for Java language. Java language using referencing pointer. So all the reference in Java is a pointer. So they don't have the difference between reference and pointer. We call it reference pointer. And then C++ language, the pointer and the reference is to have a different definition. So they use the star for ages, use the alias for the variable name. Okay. Okay. Any questions so far? So right here, this one is a summary. You need to remember what's the name, what's binding, what's the scope, what's the referencing environment. Okay. And then when you have one variable or one function, multiple alias being assigned for it, we call it overloading. So usually overloading is a function of different type, different function definition in the same class, but they got assigned with different with the same function name. We call the function name got overloading. Okay, and then if you have the same function name in different class, especially subclasses, then we call it overriding. Okay, these two terms are different. You got to understand them. So the whole environment, we call it reference environment, including the local variable, stack, heap, also global variable. Okay, everything together is called Python reference environment. Okay, querying is to pass the variable to the function. Okay, and it's also dynamicized through a Python environment. Okay, this part you need to know that what is your reference environment. Okay, so to understand what is your reference environment, there's one tool that you can use. That's called pythontutor.com. Okay, that's called pythontutor.com. Okay, pythontutor.com, you can run your program and they'll tell you what reference they are at the runtime. Okay. Okay, so when you run, it will show you step by step what are the variables. Okay. And then what is the binding environment? So the reference environment show up on the right side. This is called referencing environment or reference environment. Okay. Okay, so in that different language you can change, but among the different language, Java language, C language, C++ language, to know about the reference environments. Okay, so that's the tool to know about the reference environment. So here there is also dynamic binding and static binding. Okay, deep binding and shallow binding. Okay, you got to try to understand it. Okay, especially deep binding and shallow binding. And here show you the variables. Python deep binding. Okay, Python using deep binding. Deep binding means that you bind down to the calling environment, not the runtime environment. Okay, so you got to understand what deep binding is. There's one example here to show you what is the deep binding. Okay, you can try to run it. Okay, they are functional closure and the first class subroutines. You need to know about when you pass the variable function as variable, what happened. Okay, so first class subroutine, first class. Whenever you say first class, means that as a where you put as a variable or as the where it as a return value, it all treated as the variable. In those kind of things, we call it first class. Second class can only be passed as a parameter, but may not be used for return value. Then the variable is called second class variable. So first class means that the function name can be passed as a parameter, can also be used as a return value, can also be assigned to a variable. Then that's a first class status. So Python's function is first class status. Python's it can be used as a parameter, can also be a return value, can also be a variable. Some language like C++ or some language like Java language, it is not first class functions. Okay, so in here you need to know what is the first class definition, what is the second class definition. Okay. And multiple environment. Okay, you may have runtime have a multiple environment going on, especially when your function code deeply, multiple level code, nested code. Your environment may be got stack up. Okay, so here just tell you how the polling environment being determined in Python language. Okay. Okay, it is just one example of the nested code at this reference environment. Okay, tell you what is the reference environment. And higher order function. Higher order function means that you have a f function calling another f function calling another f function or multiple function call. Okay, it's a higher order functions. Function with function as parameter with function with parameter, we call it higher function, and you can use a currying. Okay, so you need to know how currying determine the function type. Okay, so here you have the. So this one you do have a return G. G is a return value as a function. So this G is a first order function. It also is a return value for the multiple function. So when you call it multiple function, multiply function, G function is returned, and this G function will take up one parameter called Y. So you actually pass a Y to a function, to this function. So this is Y. Well, 2 is the X. You multiply 2 is the X. So you return the function G. G had take a one parameter. While your multiple 2 is a G function but return. Okay. So that G function calling the value of 3. This is called higher order function. Okay. Okay, and then we talk about the environment for these higher order functions. Okay. You need to know about the environment diagram. And environment diagram, you go to the pythontutor.com. You will know what is environment, the environment. Okay. And the local variable, global variable, we already talked about it. Okay. And function composition, the combo multiple level of functions. Okay, and the function can refer to itself. It's called self-referencing function. Okay. Okay, anyway, these are just telling you more advanced function call techniques and the definition of the variables. Okay. Any questions so far? Any questions so far? How about any question about the homework or anything else? Also no. Okay. If no question, we are up to here today. Okay. See you next week.
Thank you. Have a good one.
Okay. Bye bye now.